All right. So just hop back to this slide real quick for male reproductive system. Remember, meiosis is controlling the formation of our gametes. And for males, we're going to start with one germ cell or spermatogonium, and we're going to end up with 4 spermatozoa. Ladies, how many really functional gametes do you make per germ cell? 1, because it's got to have all the cytoplasmic stuff associated with it. Sperm, we're going to get 4, because we're going to need a whole lot more sperm to fertilize your 1 egg than just a couple. It's going to be the clone army, that's right. All right, so we've already, back in female reproductive system, we talked about the scrotum, the sac that is going to contain the testicles external to the body. What's interesting with the scrotum is able to contract and it's able to relax, because the testes have to keep the sperm at an optimal temperature. And so if your body is too cold, then the scrotum is going to shrivel and shrink up and pull the testes closer to the body to try to keep them warmer. If your testicles are too hot, then the scrotum is going to relax and loosen, and they're going to descend away from the body to try to cool them off. That's why one of the first things that happens if you go into an infertility clinic and the problem is with the baby daddy, they're going to say you need to wear boxers. Let the scrotum do its work. Got the tighty whities, the scrotum's not really going to be able to relax and get them away from that body heat, if that's the problem. All right? So we've got the testes. This again, these are going to be homologous to the ovaries. That's where we're going to produce our sperm, and we have cells that produce the androgens, the testosterone in our body. We're going to see that our testes, they're going to have double layers of membranes, but we got a fibrous capsule. It's called the tunica albuginea. Heard that before? No. Oh, the ovaries have the tunica albuginea too, so some of the names are going to be the same for the ovaries and the testes. But unlike the ovary, each testis is going to have 250 lobules. This thing is going to be divided by this connective tissue septa. And within each lobule, we're going to have these tubules that are going to be where sperm are being formed and maturing, and these are called the seminiferous tubules. So each testis is going to have a lot. And I forget how long each one of these seminiferous tubules are, but they accommodate a lot of sperm. So within our seminiferous tubules, we're principally going to look at the cells that give rise to the sperm and the sperm in different stages of development. So the germ cells, the reproductive cells, these are going to be called the spermatogonia. And as we look at a cross section, this is an illustration. We'll see an actual histological slide next. This is going to be the basal part of our seminiferous tubule. This is the lumen of the seminiferous tubule. Down here at the base, we're going to have a spermatogonium, and that's the one right here. Then we also have supportive cells. Now, ladies, y'all don't start laughing, okay? It's not our fault. Okay. It's not our fault. It started with the sperm that fertilized the egg that gave rise to us. The cells that you see here, these really large ones illustrated beside the developing sperm, okay? These are sustentacular, which sustentacular are the supportive cells. They feed, they nourish, they take care of. That's what sustentacular means. You can call them Sertoli cells because Dr. Sertoli named them, but I've always heard them called nurse cells. Nurse? Nurse cells. Because the developing sperm, the male gamete, can't take care of itself. We didn't have a chance. We just didn't have a chance. It started before we were conceived. So without the nurse cells, the sperm would not be able to get the nutrients they need, the gas exchange they need to develop into a spermatozoa. Now, notice that not only are the nurse cells helping to support the testes, they're also releasing a hormone, an important hormone called inhibin. If the sperm count is too high, that's going to slow down or shut down sperm development. If it's too low, then this is going to shut down so that you can respond to, what is that? Follicle stimulating hormone. FSH stimulates follicular development in the ovaries, and it stimulates spermatozoa development in males.
It's the same, like exact hormone?
FSH, same hormone, comes from the same place. Yeah, same thing. So it's weird how more alike we are than we are different. I don't know why we fight all the time about our differences. It's weird. All right. Now we also have these cells that are called interstitial cells. You remember what interstitial means? We've talked about that word a couple of times. In between the tissue. And so these cells are in between the seminiferous tubules. There's our seminiferous tubule. This is the space between, and this is where you find the interstitial cells or the cells of Leydig. These are the ones that produce the androgen testosterone. And what does testosterone production, how does it, what is its trigger? Luteinizing hormone. So the sperm development is follicle stimulating hormone. Testosterone is under the control of luteinizing hormone. Again, we're using the same hormones, just in a different way. Now, the adrenal gland, we do have some of these produced in the cortical layer, right, of our adrenal cortex. It's that third deep layer. Is that the zona glomerulosa? No, the zona reticularis. That's where we have those androgens made. And you get a little bit from there, but not a lot. Most of those, the testosterones, those are going to come from the Leydig cells.
If we could take a pill or something that would increase
Leydig.
follicle stimulating hormone, would that be, like if they could develop something like that, would it be male?
Well, certainly if you could either produce more follicle stimulating hormone or respond more readily to it, that would increase development of the sperm, but inhibin would shut it down.
Right.
As you try to produce more, inhibin's going to come on in negative feedback and shut it down.
Okay, I understand.
Does the sympathetic system have anything to do with like shutting or like secreting more inhibin? Say like.
I don't think so. It's just responding to your count, the sperm
It'd be
count.
more parasympathetic, right? 'Cause that's like
You're right.
best of
Right. So again, you ask, is it the same thing? Well, guess what? Hypothalamus, gonadotrophic releasing hormone, anterior pituitary, FSH, LH. I mean, this is good. I mean, you just have to learn one of these and it applies to both of us. The only thing that differs and where it diverges in information is the response to FSH and LH. Again, we saw on the last slide, LH, the interstitial cells of Leydig to produce testosterone. FSH stimulates the nurse cells. And this is going to secrete a new protein here, androgen binding protein. And that is going to cause the testosterone to remain at a higher concentration in the seminiferous tubules to aid in the development of the sperm. So again, steps 1 and 2, same for male and female. Step 3, and the response from the gonads themselves, either the follicles or the sperm or our interstitial cells, that's where it diverges. Testosterone. Moms, if you have sons, you see a lot of this happening at puberty. The growth spurts that happen with boys. I swear from about week to week, we were buying 2 new pair of shoes for our twins. They now wear 13 and a halves. Their feet are water skis. I actually try to wear their shoes that they left at the house for working outside. I can't. They're like walking in water fins. They're so big on my feet. Growth spurt happens because of that. But it stimulates the secondary sexual characteristics. And when you look at testosterone and the influence of testosterone, it's not just those characteristics, the increased muscle mass, the increased bone density, increased red blood cells, and certainly for your sexual development here, but even your brain. Testosterone is important for your libido, and this is where females, they will get exogenous testosterone. They will go in for injections of testosterone to increase their libido if the testosterone is too low. But look also the positive benefits of testosterone, cognition and memory. That's why old guys can't remember anything. It's like, it's menopause. No, that's a thing, menopause. Libido, sex drive. Yeah, your libido is your sex drive. And they've got it spelled out here in the brain. I don't know if that works. Males' brains and sex drive are usually not. Anyway. So growth of facial hair, that's again going to be a secondary sexual characteristic of males.
So the men that grow like really patchy beards, does that just mean that they don't have enough testosterone?
No, I don't think so. I think it's sort of the same as male pattern baldness, and don't look at the back of my head. But it's just genetic and hair growth, because some people can grow really, really thick beards. Okay, yeah, go ahead.
Since 16.
Do you get your like baldness from your mom's dad, like your mom's side?
I'm not sure, but again, that would probably come from down the line somewhere. But it's more genetic than it is hormonal. Yeah, especially if it's patchy like that.
Is there a way to combat that? Like if it's just genetic, does that mean that it's never going to change?
Rogaine? I don't know. If you're going to be bald, you're going to be bald. Yeah. So this is an illustration of the stages of spermatozoa development. And so we're going to start these. This is our basal layer at the top. Here is the lumen of our seminiferous tubule here. And so first we're starting with spermatogonia. What does this word mean? Diploid. 2N, 46 chromosomes, correct. Two copies of each of our 23 chromosomes equals 46, all right? I keep repeating that because the 23 and the 46 gets kind of confusing unless you go 23 pair, a pair from mom, a pair from dad, equals 46.
I think something that trips me up in meiosis a lot is like, shouldn't there be actually like 96 or like 4N in order, because they divide 4 times to each have.
Well,
That's meiosis.
they're moving the 23 sister chromatids apart. Remember the sister chromatids? They've got their copy. So you're playing, you're right, you're playing with 96 chromosomes.
Okay, yeah.
But they're not detached until the end in anaphase meiosis 2. Right. So we got our germ cell spermatogonia. Then we produce what are called spermatocytes. You have a primary and you have a secondary spermatocyte. The secondary spermatocytes, it's such a short stage that you rarely ever see them in a histological slide. Then we have our spermatids, actually sort of 2 stages, an early spermatid and a late spermatid. And then once the sperm is released into the lumen and it's moving through the male reproductive tract, then we refer to it as a spermatozoa. But they're not swimming yet. The spermatozoa, the flagellum, does not get activated until ejaculation, and it's in the female reproductive system. Okay? So here is just a diagram of the sperm. There's the flagellum that we talked about. The mid piece, or the neck of the sperm, is solid mitochondria. Why do you need so many mitochondria in basically this package of 23 chromosomes?
It's got to go a long way.
You got them. That's the motor for the
Flagellum.
propeller, I guess you would say,
So
the
what happens
flagellum.
to that? 'Cause we don't get any from our dad.
No, you don't get the mitochondria. That all stays outside. Here in the head of the sperm, that's where the nucleus is with those 23 chromosomes. And it's covered by a cap that is called the acrosome that is filled with digestive enzymes.
So I can eat the egg.
So it can break through the corona radiata and the zona pellucida to get to the plasma membrane. and the membrane of the sperm fuse with the membrane of the oocyte and inject the nucleus. Literally, sperm are kamikaze fighter pilots.
Interesting.
Because the kamikaze pilots had hardly anything on the airplane. They lightened the load so that the plane could get to its destination. They had just enough gas to get there and not get back because it was a one-way trip. Do we all know about the kamikazes in World War II? They were the first guided missiles in existence. With people in them. Now, some debate that they were handcuffed in there. I don't know. Those are some stories, but yeah. But they were that devoted to the cause, to the emperor, to their country, that they were willing to make that sacrifice. Well, we got a lot of these kamikazes that are making the sacrifice, but unfortunately, these guys are not as smart because most of them go the wrong way. So, now this is a histological cross-section through a seminiferous tubule. Here's the connective tissue. That, you see those little bubbles right down there? That may be interstitial cell of Leydig. I'm not sure. I wish I could see more of it to know. But this is the interstitium. These cells at the bottom with the dark nuclei, those are the spermatogonia that are, this right here, that's a spermatogonia. That's a spermatogonia. And these with the large nuclei, those are your nurse cells, your Sertoli cells. Then as we move up, you can see these cells with a very condensed chromatin here. Those are your spermatocytes. They look like what? Well, it looks like they're in mitosis, right? So they're undergoing meiosis 1. So these are your spermatocytes. You don't see secondary spermatocytes. These round ones that you see all over the place, those are early spermatids. And then by the time we get close to the luminal surface, these torpedo-headed looking things, those are late spermatids. Now, just like the kamikaze pilots that jettison everything, radios, whatever was completely unnecessary, they didn't need a parachute because they weren't coming back. They were lightening the load. All of this material is shed cytoplasm that the sperm no longer need. And that's what you see out here in the lumen of the seminiferous tubule.
So what happens to that?
It just gets reabsorbed.
They're reabsorbed.
It gets reabsorbed. Yeah. Now, from the seminiferous tubules, when the spermatozoa make its way out of the seminiferous tubules in the testes, you end up in this really highly coiled tube called the epididymis. The epididymis is a place where sperm are stored. Now, if in fact you expel the sperm too soon, they haven't finished their development. So their motor's not going to run. If they stay in there too long, they're going to be reabsorbed and degenerate because you want to have effective mobile sperm to have the best chance of fertilizing the egg because we've got a shot clock.
Is that determined by ejaculating too often or too infrequently?
It's going to be your sperm count. And then, again, it's not really how much you ejaculate necessarily, because, again, it's going to be reabsorbed if you don't ejaculate at a certain rate. Okay. And, again, if you ever deal with infertility, ladies, don't let the guy fool you. Having sex several times a day is not the answer. Guys are going to try to pull that on you. That's not the answer. Again, for this sort of reason, you have to build up an adequate supply, and you can't do that with such frequent intercourse. It's not going to work. What makes an erectile dysfunction? There are a number of different things, and we'll talk to it when we get to the penis because that's really where ED hits, is the penile tissue.
Will that also like make a male infertile, or how does that work?
With erectile dysfunction, you have to have a certain state of erection to be able to penetrate the vagina, but there are a number of prostheses and pills you can take now. Viagra was the first one. See out. They've got a bunch. People are making money hand over fist with that stuff. But as long as you can have an erection, then that's going to be where you can inseminate the female. So really the erectile dysfunction is just for the intercourse part. of it. And there are various ways can get around that. So the epididymis, we can see, here's our seminiferous tubules. Then we have these other connecting tubules. We're not going to name all of these in here. Then we get to the epididymis, where you have the head of the epididymis, the tail, and that then is going to coalesce. And you have several of these spaghetti strands that are going to coalesce and feed into the one tube, the vas deferens or the ductus deferens, two names for the same thing. And this is going to be the one that comes from each testis that comes up, and it re-enters the body through the inguinal canal. It's down in the perineum. And this is going to be the transport tube that brings the sperm to the penis. Now, if you follow the vas deferens, you're going to see that the vas deferens goes through and fuses with our first gland we're going to talk about in the next slide. That's called the seminal vesicle. Then we form this duct from the seminal vesicle down to the urethra. That's called the ejaculatory duct. And the ejaculatory duct is going to form with the ureter coming from the bladder, and that then is going to form the penile urethra coming out. But the ejaculatory duct, that's going to run through the prostate gland. And then down here in one of our erectile tissues in the root of the penis, we have this bulbourethral gland. So we have three glands that we're going to talk about that are critical for keeping the sperm nourished, alive, and healthy. All right? Now, the other thing that I wanted to mention, the vas deferens, this is the tube that during a vasectomy is cut. Okay, it's typically going to be out here in the spermatic cord, and basically there's going to be an incision through the scrotum. The vas deferens is going to be separated from the blood vessels and everything, and you're going to cut out a segment. You're going to suture the ends, and often they'll cauterize the ends as well. So they're taking the bridge out. So the sperm can't get from the testes to the penis. And in that case, they're all resorbed, just like we saw if they're too old in the epididymis.
So how is that reversible?
It's reversible if they can reattach the vas deferens together. And I think the success rate on reattachments, and it's going to depend on how long it's been since you had the vasectomy, I think the reattachment, the successful reattachment rate is very low, maybe 25%. Yeah.
So like testicular torsion, is that what this?
Testicular, yeah, okay, ovarian torsion, if we went back to that picture, there are ligaments that are holding the ovaries in place. If they were to twist, those membranes of the ligaments, the broad ligament and the round ligament, as they twist, they're going to restrict the blood flow to the ovary, and the ovary will die. So in this case, you've got blood vessels coming in here beside the vas deferens in the spermatic cord, and if these testes twist, they could pinch off that blood supply as well. So yeah, we don't want torsion of any of those parts.
Can they have an overproduction of sperm?
Can a male have an overproduction of sperm?
Yeah, but since it like continues to make, and since it has nowhere to go, like I know it'll just reabsorb itself, but like what if it makes too much?
Well, you've got inhibin, that hormone that's secreted in the testes if there's too many sperm. I would assume that there could be a condition, but I'm not aware of what that condition would be. So, I think we covered those things. All right. Now, our glands that we talked about, those three glands. First, the seminal vesicle. This is going to contribute 70% of the volume that you're going to have in semen, the ejaculate, that's coming from the penis. And this is going to be important because all of these things are going to be supporting up to 500 million sperm per ejaculate. 500 million sperm. It takes a lot of sperm for one to do the job. So when you see a bunch of guys on a construction crew, one's doing the work and 20 are looking around watching, that's why. It's not our fault. I'm trying, guys. It's not working? Okay. All right. So the seminal vesicles produce an alkaline fluid. Because what did we say is produced in the female reproductive tract to fight off infection? Acid. So that ejaculate is neutralizing the acid that would kill the sperm. See, ladies, y'all don't even like men. Your bodies are trying to ward us off. But we have a backup. Ha ha. The seminal vesicle. Now, the nurse cells supported the sperm because they can't cook, they can't feed themselves, right? Well, these glands are giving us more food. It's like the last meal for the sperm. Fructose. It's like, here, enjoy this, and we who are about to die salute you. You got prostaglandins. This is going to open up the cervix. That's a signal to loosen that because the sperm have to get through the os of the cervix to get into the uterus, to get to the fallopian tubes. And then there's also some enzymes that are inside the semen that cause the semen to gel, to be thick, because the semen needs to stay in place. It doesn't need to just run out. That would defeat the purpose. Now we're also going to see there's a component of semen that in a certain period of time, it causes the liquefaction of it, so that it's not just going to be gel the whole time. Now that's seminal vesicles.
So hold on. The liquid, is that gonna be like later so it can like swim? Because I feel like
It's going to be some, well, the sperm is, when the sperm get in there, they're gone. But it is going to be a slow release as well. Because here's what we're going to see. What we're going to see as we talk about fertilization in the next unit, sperm have been found in the ampulla of the fallopian tube after ejaculation, 5 minutes.
Wait, what?
5 minutes sperm after the ejaculation into the female reproductive system. They've been in the ampulla. 5 minutes. We're microscopic. These little microscopic. I can't run a mile. And these, I don't know. Okay, we need to transfer like our miles into how long these sperm based on scale. That's a long ways.
Wait, so how long does someone have to like 24 hours. Plan B and stuff? Like if they want to take that. Like,
Well, again, the eggs got to be in the right place. The sperm have to be healthy and in the right place. You know,
Emergency contraception.
y'all are killing me. Okay, can we cover those in the development part? Let's cover those in the development part with implantation and that kind of stuff. Okay? Otherwise, we'll never finish.
Okay, you just asked this. Dr. Google said semen come out at 28 miles per hour.
28 miles per hour.
it's almost like a cheetah.
They are fast. All right, so the prostate gland is adding as well. The prostate gland produces calcium. Now, hang on to that because that's going to be important for what we're going to do here in just a few minutes. Calcium, again, is everywhere. Zinc, antibacterial, preservation of the DNA in the sperm, because if the sperm gets there but it's damaged, this DNA has defeated the purpose. And then we also have citric acid. Again, this is possibly supporting the health of the sperm. And then we've got this seminal plasmin, which is an antibiotic. And this is going to help with any sort of vaginal, cervical, reproductive tract infection. All right. Now, gentlemen, this is the best news of the day. All right. The prostate gland produces prostate-specific antigen. This is, in fact, the enzyme that helps to liquefy the semen 15 to 30 minutes after ejaculation. So I don't think it's to release the sperm. That takes too long. But the good news for the guys, PSA can be detected in your bloodstream. And there is a direct correlation between increased PSA and prostate cancer. So guess what you don't have to worry about anymore. This is not indicated. This is not indicated. Yeah. It's just check your PSA and yeah.
So they still haven't changed anything for women.
No, I ain't saying enough for y'all.
Wait, what if we?
Oh, do I have to explain this right here?
It's whatever.
If my doctor says, what's up, brother?
Okay.
Is that what you're talking about?
Digital rectal exam. And digital is not electronic. Because the way doctors tell if your prostate is too large is by feeling it.
Don't do your finger like that.
And the most direct path is through the anus. So, yeah, no, blood. Now, if your PSA goes up, the glove's coming on.
So you just need to do a blood test instead
Do a blood test, a regular blood test. I get one every 6 months because my dad had prostate cancer. So,
So
yeah.
he had to get his booty hole stuck all the time.
I'm not even going to, I don't want to think or talk about what happened to him. I can't. Okay. And it's kind of like, you know, at a certain age, they recommend you to have a colonoscopy. Okay. Now, y'all might not be as excited about this. Y'all might not be as excited about this as me. Now, you don't have to have a colonoscopy. Cologuard, the poop in the bucket. Yeah, you.
When they do it, though.
I don't care.
It's not worth like.
No, all you got to do is just poop in a little jar, a fairly big jar. You put it in this holder on the toilet, you poop in it, seal it up, and mail it back. And only if they find any cancer markers in that do you have to have a colonoscopy.
Trust your wife enough to like how do people do that?
I'm a good shot. I was a quarterback. I'm a good shot, man.
Isn't there other reasons for colonoscopy though?
Yes.
Maybe, but I'm going to put that off as long as I can.